let's not get into the discussion of how to prepare at all. Am I audible to people who are online? Amshini, can you please confirm?
Yes, sir, you're audible.
Oh. Is it coming from there? Can you please respond again? Amshini, can you please respond again?
Yes, sir, you're audible.
Okay. Okay. So we get started. So this is from your 11th standard. If you see math, right? So you have these chapter 6. These are all the units basically. They're not the chapters, I would rather say they are the units. So you have this first unit called as 6n functions, right? Then you have this algebra part, coordinate geometry, calculus, statistics and property. You had 5 units, right? Let me tell you what are all the units that are important for this year. So what did you learn in your sets? So you learned about how to organize things, how to collect a particular. If I give you a data, I give you random data, and your job is to okay, perfect. Now listen. What were we discussing? Yeah. So if I give you random data, your job, I'll say you need to arrange all the data in a particular format and give me, right? So you'll take the help of which branch? Obviously, set. Okay. So now an important question to be asked. Is set an independent chapter? Is there any necessity of learning sets? Did you apply it anywhere in any other branches of your math in your 11th standard? Property for writing the sample space. So apart from that, you didn't apply it anywhere. Forgot the main part. Relations and functions. The most important thing that you need is set, right? Because you have different kinds of relations that are being formed. So you didn't learn about the different types of relations last year, but you understood what is a relation and what is a function. You learned about different kinds of functions last year, right? This year you will be learning about different types of relations and functions. Okay. In algebra part, what did you learn last year? You had permutations, combinations, you had binomial theorem, and all those things, right? Mostly those topics will not get touched this year, except the fact that here and there, a little bit of combination is needed for you to understand how to select things, which will be applying it in probability. It's not a very big thing. It can be taught easily. Just recollect it. If you don't know the whole story, don't worry about it. So coordinate geometry, what did you learn? You mainly learned about straight lines and conic sections. Conic sections. Then you had a 3-dimensional geometry also, which is very, very, very basic. So whatever you learned in your 10th coordinate geometry, the same replicated in 3-dimensional geometry in your 12th. Correct? Calculus. How many of you hate it? Parsara, pudikuma. You like it? Huh? Easier? In detail. How many of you feel it easy? You like it? Which one you like? Limits. So you're good with limits. You understood why you're learning limits. So if I put a question like this, do you guys have clarity? Most of you think that math is a formula subject, correct? In the thought will come in, right? This is a very generic thought. How many of you have learned the theory behind math properly? How many of you have questions saying that why are we learning this chapter? You have asked. So if I ask you, you'll be able to answer. For example, if I ask you what is the application of relations and functions, do we need it actually? Is it important? Do you think relations and functions are important? Do we need to learn it? If at all you say it is important, where will you apply it? That is set. Okay, you are doing it with set and all those things. Why do you need functions? Why do you need relations? that you can, so for the answer that you gave, I can do it in an Excel sheet and finish it with the technology I have in today's date. Why do I need to learn all these mathematical things? It's a headache. Give me graphs. That's right. Actually, that is one of the valid reasons. So what will you use? You will use relations or functions to draw graphs? You mainly use functions. Okay. So for you, you're saying that relations and functions are important only for, okay, one of the applications is graphs, I accept it. Anything else? So you need calculus. Okay, I will ask the next question. Why do you need calculus? Why was calculus invented in the first place? Why is it needed? Only headache for us. Too many formula, too many things. Bring trigonometry headache for me. I can't solve. By doing it, what are you going to achieve? Who is bothered about it? Why do you want to disturb nature? To predict a value. What value you want to predict? In stocks, you know how to trade it. Now, confident as stocks and anything that you understand. He's scared that I'm going to ask him. He's putting his head down. Answer. Don't worry. It's a discussion. I'm trying to understand. Shubham, you want to try that? So one of our friends is saying, the stocks are. One guy is saying he wants to find some small parameter. I'm saying I'm not worried about it. You have it with yourself. Nathan, mark. Anything else? I'm worried because you didn't apply all these things in physics at all. You have not applied all these things in physics. This is only for the sake of derivations. Why do you do that? So I'll create a link. Okay, I'll try to create it, understand. You answer this question, you understand. You see, when I asked you coordinate geometry, you told me you learn straight lines, correct? Straight lines, what is the important topic you need to understand? What is the base of straight lines? What in the പഠിച്ചിരിക്കുന്ന straight lines? Don't say distance formula, section formula. First thing, what did you concentrate? Something related to tan theta. Slope of a line, correct? I'm not concerned. What will I do? Why do I need it? Just to write y is equal to mx plus c. Then there should be some application of what you're studying, right? Why do we do that? How steep or something? Okay, that is right. 1 minute, somebody has answered. Finding slope. Okay. So you use straight lines, and if you know 2 points, you will be able to find the slope of it. Okay. Okay, I'll have it with that. So generally, slope is a concept which is used for any shape, or is it only for straight lines? Slope can be used for any shape, or is it only for straight line? It is only for straight line. Okay. If it is not a straight line and I give you a task of finding the slope, what will you do? So you will draw a tangent, and what will you do to that function to get that slope of it? You differentiate. By differentiating, you get the slope of the curve at random points. If I want it at a particular point, what should I do? Take that point and substitute it. Correct? Other than applications of differentiation. So if somebody asks you why do you differentiate, what will you say? I'm expecting more appropriate answer. Differentiation is a most misleading thing. Many people tell me to break it into small parts and find out something. I don't know what small parts and what will I do with it. You actually find the slope of a curve at a particular point. So that is the reason why calculus was invented. Okay, the limits concept and everything. So if you ask me a question, if you think of all these concepts, right, are you finding an accurate value or an approximate value? Calculus, is it giving you an accurate value or an approximate value? It gives you an approximate value. It doesn't give you an accurate value. So if you need accurate value of a straight line, the slope of a straight line, you need to do only with the straight lines concept. But if it deviates from the straight line concept, we have no other tool. I told you about the tool, right? We have no other mathematical tool in our hand except using differentiation. But for you to understand differentiation, you need to understand limits. So limits is the base of calculus. But before limits, you need to understand functions. But before you understand functions, you need to understand relations. Before relations, you need to know what is a set. Reverse analysis. So that is how the chapters are actually connected. Okay. So what else is there in calculus? You have learned limits and differentiation, except integration. You're going to learn. So everybody is a physics student, right? Yeah. So then you're going to learn integration. Why do we do that? So I told you differentiation is to find the slope of a curve at a given point. Then why do we learn integration? Area under the curve. Don't use the word slope. Area under the curve with respect to any one of the axes is what is the main application of the integration. Okay, so whatever I'm telling will reflect in the paper in your 12th standard. Okay. Then you learned about statistics and probability. What did you learn in your statistics? Why are these two chapters important? I'll again say they are not important. What will you do with them? Any idea? Let me see how much you people can think. Statistics is a user. Analyze the data. By doing what? What operations do you do to analyze the data? So you're saying sets is something which is used to organize data, and statistics is something which is used to analyze the data. Correct? Is that your understanding? Okay. So mean, median, mode, and calculate. By doing that, what are you trying to achieve? Why do we need to calculate mean? I have hundreds of data. I leave it as it is. Right? I'm not bothered. Why do I need a mean? Accounts in the sense. Let me make it simple. See, suppose you go to a company tomorrow. Let's say you're working for Apple. Okay. They say you've seen promotions and how they do and all those things. Next time observe it. Okay. See with this kind of a mind you like math. Okay. So they would have you ever seen ads for phones in TV while you're watching cricket or something? Some ads with Samsung ones they will promote it, right? 108 megapixel camera, screen size you do. They say all those things. When they say screen size, what are they trying to talk about? So I have this mobile in my hand. Okay, low iPhone model. They say screen size is 6 inches. Which side should I take the 6 inches? Right? That's wrong. It is right. Whether it is your TV, whether it is a projector's vision, it is a diagonal that you wish. Otherwise, there is something called as aspect ratio that they will decide. So for example, I'm showing you a presentation, right? I'll show you. You're able to see my screen. I have an iPad in. Okay, I'm projecting an iPad into a laptop. In my iPad, this is not actually a black space. That is the hardware. Okay, this is not a black space. It's a hardware. So screen is the data full. It's a PDF completely there here. This is the screen. Yeah. This is the screen part. Are you able to see the data completely here? Yes or no? Right. But when you see it here or in my laptop, this is the thing that I'm able to see in my laptop. Why is it not happening? Because I'll tell you something, this slightly difficult concept, but try to understand. The aspect ratio of this device is 4:3. Means if this is 4 units, this is 3 units of whatever it is. Whereas my laptop screen works on 16:9. Similar is the case with your TVs also. That is why when you project your laptop data into it, you can see it in full size. Ugly take aspect ratio. If you want to see 4:3, it will appear something like this. Okay. So why I'm telling all these things is tomorrow if you go to a manufacturing company, let's say with the help of any, you are getting into some R&D department, and you are going to decide the particular screen size where everything has to be perfect. then what you need to know is first is the diagonal thing, and the second is you're going, when you say R&D, you're going to do an experiment. I told this whole story so that you'll understand why you're doing something in your lab. Physics lab, you're doing experiments. You use vernier caliper, you use screw gauge, and all those things. Why did you do that experiment? With that, you found out some value. And when you do that experiment, how many times will you repeat it? So more number of times you repeat, more accurate value is possible for you, because what will you do at the end? You will calculate the average. So where is the idea of average coming from? That is a very basic thing I'm trying to talk about, but that is not the simplest application of why statistics. Statistics is mainly used to analyze data also. As you go higher, right, like you told about the stocks and all those things, right? The probabilical statistics comes that they call it as statistical probability. Why they call it as statistical probability is something has happened in the past, right? See, for example, tomorrow you want to buy iPhone and I give you an MI phone. Okay, which one will give you more trust? Let's yeah, yeah, please. Past data shows people would have given you a feedback, right? They would have given a feedback to Apple and all those things. So based on the past feedback, you can predict how your future is going to be. Means you're going to say, if I invest the 60,000 into this mobile, I need not worry about it for the next 5 years. So with the past data that you have, you predict the future. That is where the concept of probability and statistics comes. That is why they always combine these two. When you go for higher study, especially commerce and people who are doing business, right, they need it a lot. And secondly, you would have seen these games and all. I'm not sure if you watch English movies and all. You have seen this game called poker. They do it in casinos and all, right? You need not play it, that's a different story, but you have heard about it, right? Poker. So it's a 3-card game. So based on the past and something, you can predict the future. So actually, it is a part of your curriculum itself, but they will not tell in these languages, which I'm trying to speak. The questions will be framed generically, but this is how I think. So Bernoulli's trials and all those things are there. There are certain mathematical expressions which can be used to predict the future. Okay, you have it actually. Okay, so that is why the subject probability is very interesting. So I hope you understood why you have learned 11th standard. If you see your 12th standard is almost similar. Almost similar. Let me continue. Oh, sorry, this term. Sorry. There's the thing. So mathematics, you see, is it not the same story? Nothing different. So relations and functions, they have already learned. You can ask me, sir, what different is going to come? You're going to learn something slightly in depth. There you saw what is a relation. Now you'll understand what are the different types of relations. There you see what is a function. Now you'll see what are the different types of functions. Okay. Second is algebra part. Algebra is slightly different compared to the previous one. So there you learned about permutations, combinations, and Bernoulli's theorem. Here you will be learning about matrices and determinants. How many of you are computer science engineers? Like computer science students. Everyone, most of you. But you know basics of computers, right? You know how programming works and all those things. You have heard about arrays? No, obviously you for loop and all those things you write it, right? So same logic. Matrices is something which you write it on a paper. The for loop is the representation of matrices in a computer language. So it's again about all the data that I give you, how you are going to arrange it in the form of rows and columns. That chapter will slightly deal it in a different way. Then calculus. Same limits with a different name this year. Now I didn't ask you an important question. Why are we learning limits in the first place? Differentiation, you told me finding the slope of a tangent, etc. Integration, you told me finding the area under the curve, etc. But why are we learning limits? Don't say to apply it in differentiation. So there should be a reason for it also. Let me say, I have a curve like this. Okay. There's y-axis, x-axis. Okay. If I ask you to differentiate it, will you be able to do it? If I ask you to differentiate, will you be able to do it? So what will be the question you'll ask me? Sir, give me the equation of the curve. I will differentiate it. For example, I'm saying y is equal to x square plus 2x. You will be able to differentiate. Okay. The same graph, it's the same graph, but what is the difference? There is one break. Right? If I ask you, will you be able to differentiate it? Answer is no. Why? Because graphically, if you see, it is not continuous at a particular point. So use the right word, continuous. Okay, it is not continuous at a given point. But if you have to speak in mathematical language, you will say that limit does not exist at this. So when I say limit does not exist, left limit and right limit is not equal to the function value. That is the meaning of it. So you have learned this left limit and right limit, right? The same logic is applied. Last year's languages, you will be learning it as left limit is equal to right limit is equal to function value. This year, if that kind of a scenario exists, you will be using the word the function is continuous. That's it. Same story, different way. That's it. Okay. Then differentiation, of course, you'll be learning slightly in depth that we'll work upon. Then we have integration and applications of integrals. And the last one is differential equations. So if I have to tell you what is a simple differential equation, you guys have already seen it in physics itself. In equations of motion, if I have A is equal to dv by dt, this is called as a differential equation. Name itself is differential equation. Equation is something where there is an equal to sign. So acceleration is equal to dv by dt, the meaning another. So dv by dt is a differential coefficient. Okay. Then if I have to solve this, what will I do? I'll write dv is equal to a dt. Then to remove differentiation, the counter operation is, you have done this in your physics, right? So this method is what we call it as solving a differential equation. So a is equal to dv by dt is acceleration is equal to rate of change of velocity according to physics. But the same in terms of mathematics, you say a is equal to dv by dt is a differential equation. That's it. So both mean this. Okay. Am I clear, guys? Then you have something called as linear programming. So this linear programming is also something which is important for people who are into business, because this will teach you how to optimize. So you have certain resources in your hand. Okay. Let's say I'll give you a best example. Let's say you need to complete a project. Okay. And when you need to complete that project, let's say the requirement is 5 members. But unfortunately, 3 of them are not well on a particular day, only 2 of them are available. So what will you start doing? You have only 2 days of deadline. What will you start doing? How will your brain work? You will give up or you will try to do something. Let's say your mindset is optimistic. You don't want to give up. So you will split among yourself based on what particular topic you are specialized in. So that's what we call it as optimization. Same logic is there, but it is going to be in terms of business and money. That's it. Okay. So linear programming, if you ask me, it is an extension of your last year's chapter called as linear inequalities. Name it simple. So linear inequalities basics is needed for linear programming. Purida. So this is all about your first term, and the second term you have calculus. So first term calculus, this year it happened, but I'm not sure if it's going to be the same thing. First term calculus had continuity and differentiability, that is limits and differentiation, applications of differentiation. Second level, you have integrals, applications of integrals and differential equations. So integrals, applications of integrals and differential equation. Then you have another chapter called vectors and three-dimensional geometry. This three-dimensional geometry is not exactly the same as you learned last year. Okay, like how you started writing the equations of different straight lines in straight lines chapter. Y is equal to mx plus c, y minus y1 is equal to mx plus c. Those things are there, right? Similarly, you start writing the equations for lines in three-dimensional. Okay. Then you have obviously the probability chapter. I told you about the casino thing and all, right? The poker and all those things. The logics will come. Okay. So are you guys able to understand how to study math? So don't look at it like a formula subject. The most interesting thing when you start asking the right questions. You start visualizing it and we will learn. Okay. So with this basics, can I start the first chapter, that is relations and functions? Yep. So just give me a second. So have a date. Write today's date and start taking down your notes. Relations and functions. This week back. Just be back 2 minutes. So chapter 2 in your 11th standard was relations and functions. This year it is chapter 1. So I don't want to directly jump into chapter 2. I'm not sure how many of you have mastered it properly. I'll discuss certain basics and I'll go to this year's topic. Okay. So I have certain questions to ask. First important question. What is the difference between a relation and a function? Before that, for you to form a relation, what is a prerequisite? What do you need in your mind? So what is the prerequisite? For you to frame a relation, you need to basically need two non-empty sets. Right? You have two sets A and B. Then between those two sets, you can do an important mathematical operation. What is it called as? I've already showed you. It's called Cartesian product of sets, which is written as A and X in between B. How do you read it? You read it as A cross B. Right? So what does A cross B represent? So how do you write it in the set builder form? So how do you write it, guys? So before you understand Cartesian product, you need to know something called as ordered pairs. So what are ordered pairs? What are ordered pairs, guys? So you have a bracket like this, right? If I write 1 comma 2, what am I trying to tell another person who's reading my paper? So if I write this as 1 comma 2, what will you try to understand from this data? Which set, first or second? Okay, the first element is from the first set and the second element is from the second set. So connecting all the dots, right? I'll tell you why we are learning it. So you have one set, let it be however it is, another set, let's say x1, x2, so on till xn, and you have y1, y2, so on till yn. You have something like that, right? Each element from the set A can be related to an element in set B in whatever manner you want. There is no restriction. It can be related. So one element can be related to multiple elements in set B also, right? But only thing is, every time you cannot represent it using this diagram. What is this? What diagram is this? An arrow diagram. Right? So you cannot, every time you cannot use an arrow diagram and keep representing. So we need to make our job simple by giving it a universal notation. That is where we came up with the concept of ordered pairs. Okay. So when you write 1 comma 2, you're saying 1 has come from this and 2 has come from set. Right? slightly unstable. Okay. So let me give you another perspective to this. So the other perspective I'm trying to say is the dependent variable. What do I mean by that? Just a minute, guys. Those who are online, just give me a second. Right. We hope now there should not be an issue. So when you take a graph, okay, when you take a graph, what is most important for you to plot graph? You need, so graph is generally two-dimensional, right? You draw it on a paper. So when you do that, you need to know the coordinates of that particular point. So where this is related to x and this is related to y. So 1, 2 means you know it is at a distance of 1 unit from the origin along x-axis, and it is at a distance of 2 units from the origin along y-axis. So you're able to understand all these things are related to an important parameter called as ordered pair. Okay. So I'll be able to draw this kind of, I'll come to the point. Okay. Yeah, you understood what is ordered pair. Now you know what is Cartesian product. So if you have two non-empty sets A and B, then if you write all the ordered pairs x comma y, where x comes from the set A, that is the first set, and y comes from the set B, then you call that particular set as the Cartesian product set. Right. So you're going to have, right. So if suppose the question is A is equal to 1, 2, 3, B is equal to 4, 5, a very simple question. What is A cross B? How many ordered pairs can you form? 6, because 3 are there from set A, 2 are there from set. So 3 into 2 is going to give you the number of Cartesian products. So 1, 4, 2, 4, 3, 4, 1, 5, 2, 5, 3, 5. You understand how they have come? Similarly, if you write B cross A, what are you going to get? 4, 1, 4, 2, 4, 3, 5, 1, 5, 2, 5, 3. So both have 6 number of ordered pairs only. Doubt. 1 minute. So in both the sets you have same number of Cartesian product, but the ordered pair is different. Okay. So this is Cartesian product. Then what is relation? Then what is relation? Okay, you need a condition, accept it. But what will that condition? Okay, like you're trying to tell me in terms of generic parameters, but I'm asking a question of why and how this ordered pair and Cartesian product of sets is going to help us to form a relation. By knowing the particular connection between two values, how are you going to take it? I want you to give a mathematical definition. That's what I'm asking. Read the second line. So what is it? So it is a subset of the Cartesian product that you write. Okay, so if you have two non-empty sets and you can define a relation R from set A to set B, then how can you define it? If you know the condition, by knowing the condition, you can derive the subset. So first job is you always need to write the Cartesian product of sets, and then from there you need to choose only those ordered pairs which will suit that particular problem. That is the meaning of subset. So when it comes to subset, it can be the whole set also. Are you able to understand what I'm trying to say? Is that clear? Right? So it is a subset of the Cartesian product set A cross B. Okay. The subset is derived by describing a relationship between the first element and the second element of whom of the ordered pairs in the Cartesian product A cross B. Right. Having this in mind, now I have another question to be asked. Then what is the function? What is a function?
All the elements of set A are related to all elements of set A.
All the elements of set A are related to all the elements of set A. Okay, you're using too complicated language. Tell it in a way that everybody can understand. Each element will be associated only with only one element in the second set. So you use the word every element in set A should be related to every element in set B, not necessary. Every element in set A should be a part of the relation, but it should be mapped only to one element in the second set. So when you draw something like this, you use the word like domain, codomain, something. What is it? Every domain will have a unique range. What do you mean by unique range? Is it so? Is it so? Think about it. When you're talking about two different functions, right, or relations, why will the same elements be in set A and set B in both the cases? Why do we have to have the concept of domain and range here? So what is domain basically? What is domain? What is your understanding of domain? If I ask you what is domain, what would you say? Anybody? First element of set A is a domain. Is that right? First element of set. I mean, the first element of the ordered pairs. If you write the set of the first element of ordered pairs, you call it as a domain of whom? Of the relation or the function? Of the relation. Then what about function? So tell me one thing honestly, are you guys clear with what are the differences? Is everyone convinced with, you know what are the differences? So if I have to give you a block diagram, right? So from everything that I've understood, if I have to give you a block diagram, I understood that first knowledge that I need to have is about sets. So from sets, what do I need to have? I need to have the knowledge of ordered pairs. From the knowledge of ordered pairs, I need to have the knowledge of, actually Cartesian product comes first. So because Cartesian product is the one which gives rise to ordered pairs, right? So Cartesian product and Cartesian product will give rise to ordered pairs, right? From ordered pairs, if I take the subset, I will get a relation, and from relation, if I take another subset, I get a, that's it. Is that right? If I have to simplify things, this is what I understood. Am I right or not? Right. So first you need to know sets. So if two non-empty sets are given to you, first thing that you do is blindly do Cartesian product between them. The Cartesian product is going to give you an output called as ordered pairs. From those ordered pairs, choose only those ordered pairs which are given in the particular relationship. Okay. From there, what will you do? You take another subset which will define the function. So function is a subset of relation. Relation is a subset of Cartesian product. Is that clear, guys? So this is how it works. Okay. Now, domain and domain, codomain range, I'll come to it slowly. So this knowledge is more than sufficient for me to explain the concept in your 12th standard. Now we are getting into the concept of your 12th standard. So they asked us to recall, recall the notation of relations and functions from your 11th standard. So that is the same story that they have given. So everybody is comfortable with the set filter form, right? So how do you read it? First example, what is the meaning of this? So there is a set of what? Is it a set of elements or a set of ordered pairs? So a set of ordered pairs generally is a relation, right? So set of ordered pairs belong to whom? Cartesian product. Correct? Huh? So Cartesian product, the dot, how will you read it? Such that A is the brother of B. So first element, the first person in the element belongs is the brother of the second person in the element. Okay, next is A comma B belongs to A cross B such that A is a sister of B. So you are able to understand all these things, right? So I am not getting into these details. Now, having the basics of relations in our mind, can we categorize them into different types of relations is what my question is. Okay. So one difference. I want to stress on this point, guys. So in the previous case, when I told you how many sets do you need for you to write Cartesian product? So Cartesian product, what is the definition? Say when you have two non-empty sets A and B, then you write A cross B is equal to a set of ordered pairs. Correct? Is it there in your mind? Having this in mind, we understood that for you to write a relation, we need two non-empty sets. But what if those two non-empty sets are the set itself? In the sense, in the previous year, you have learned two different sets, A cross B. But this year relation, for you to define the types of relations, the first thing you need to know is the Cartesian product is done from the set to itself. That is why every time you try to define the different types of relation in your 12th standard, or for that matter, if you have to define types of relation, you need to do it from one set. Am I clear with this point? This should be the first thing that will get registered in your mind. So in this section, we would like to study different types of relation. We know that relation in set A, every statement or every definition starts with this word. A relation in set A is a subset of whom? The Cartesian product of the set with itself. That is A cross A. Okay, so from this, what you can conclude is if you take an empty set phi and if you take the set A cross A, these are called as extreme functions. Sorry, extreme relations, not functions. Sorry. Why do we call them as extreme relations? Because when you write the Cartesian product, if you write the subset as null set, what are you trying to say? No element in the ordered pair are related to each other. Correct? So that gives you 0. When you write A cross A, what will you do? You take the whole Cartesian product. That gives you 1. So between 0 and 1, these are the extreme values. In between only, you will have different types of relations that are derived. Are you able to understand? This is a slightly complicated concept. Is there anyone who's not clear with what I mentioned? Anyone who wants me to repeat? Understood? Nitin? Ashida, understood? You're not clear? I'll repeat it. Listen. So I have set A. Okay, I have set A, which is 1, 2, 3. Set A again is going to be 1, 2, 3 only because I'm defining A cross A. So what will be A cross A? Can you tell me all the elements that are possible? For simplicity, I'll make it simple. Or I'll make it less. 1, 2, 1, 2. What are the ordered pairs? 1, 1, 2, 1, 2, 2. Right. So you have learned something called as power set. Right. When you talk about the subset of a given set, null set and the set itself can be called as a subset of itself. You know this factor, right? You know this factor, right? So from this, I can say null set is one of the subset. So when I write null set, mathematically, I'm writing it as null set, means 0. But what does it mean in terms of relation? It means that you have different ordered pairs, right? These ordered pairs do not have any relation among them. So this 1, 1 has no meaning. 1, 2 has no meaning. That is the meaning of writing null set. If I write A cross A, what am I trying to say? Every ordered pair, every element in every ordered pair is related to each other. You have to understand. So when you write these two, null set and A cross A are given a special name called as extreme relations because 0 is the least value, A cross A is the maximum value. These are two extremes. So that is why we call them as extreme functions. So they have given an example. See, for illustration, consider a relation R and set A. That is how every statement will be there. And set A contains the elements 1, 2, 3, 4 given by R is equal to A comma B. So your job is to write ordered pair A comma B in a way that the element A and B are related as what? A minus B should always give you 10. Is there a possibility? So what will be the output of it? It's a null set. Means you can do Cartesian product. Cartesian product panna mudiyuma, right? Cartesian product has no condition. By default, A cross take that set and multiply it with that set itself. Multiply in the sense collect all the elements. So when I write ordered Cartesian product 1, 1, 1, 2, it goes on till 1, 4. Correct? Last, what will be the last element? There will be 16 elements. So last element will be 4, 4. in these ordered pairs, you take any ordered pair. Tell me one such ordered pair where you take the second number and subtract it from the first number, which will give you a 10. No number, because the maximum number that is possible itself is 4. So that is why if I have to frame a relation, it is going to be a null set. Okay, let's say another relation. This is called empty set because no order satisfies the condition a minus b. Whereas if I define another relation r dash or r prime such that, how am I defining it? I'm going to take the set of ordered pairs a comma b such that the magnitude, that is the modulus of a minus b, is always greater than or equal to 0. Whole a cross a will come because 1 minus 1 is going to give you 0. 1 minus 2 is going to give you minus 1, but you're taking the modulus of it, which is 1. So by default, you can say modulus is always greater than 0 because it gives you a positive value. And the least value you can take is 0. You may not even solve. So by default, even if they give you elements till 100, like 1 to 100 also, you can say this condition is satisfied. This is a universal set. So R dash is what? A cross. So the relation a minus b is equal to 10 is a null set, and the relation modulus of a minus b is greater than or equal to 0 is a whole set, universal set. So these two are called extreme conditions with respect to set with respect to set A, which is 1, 2, 3. Are you able to understand this? Right? So these are the extreme relations. These two extreme examples lead us to the following definition. That is, a relation R in set A, you can call it as an empty relation if no element of set A is related to any other element of itself. Okay, that is R is equal to null set, which is a subset of A cross A. This is the mathematical way of writing it, but you need to understand the context. Right? Are you guys clear with this? No confusion, right? Next time you will be able to answer. So R is equal to null set, where that null set comes from where? Null set is a subset of the Cartesian product A cross A. So this is what needs to go into your short notes. Okay. Next, definition 2 is the relation R in set A is called as universal relation. Under what scenario? R is equal to A cross A. You will not write the subset of A cross A because it's a universal. R is equal to A cross A. Means if the Cartesian product is exactly equal to the relation, we say it is a universal relation, not a set. Universal relation. Okay, what is the other name for it? They are called extreme relations, no doubt in it, but they are also called as trivial relations. Don't get confused if this word comes in your exam. Clear, guys? So with this knowledge, let's try to solve one more example. So let A be the set of all students in which school? In a boys' school. Okay. We need to show. So whatever they are going to give us, true. So show that the relation R in A is given by R is equal to A comma B, where A is a sister of B. What kind of a relation is it? It's an null set because how can a boy be a sister of another boy? So it's a null set, and R dash is equal to A comma B such that the difference between heights of A and B is 3 meters. So when they say difference, right, there are two words. Okay, you need to remember. One is called as subtraction, and the second is called as difference. What is the meaning of it? A minus B is equal to 10. Is it subtraction or difference? It is called subtraction. So in subtraction, what will happen is you take the sign into consideration. So 1 minus 2 is minus 1. 2 minus 1 is 1. But if I rephrase the question as the difference between 1 and 2, you will say 1. You will not say plus 1 or minus 1. It's a very simple point, guys. Are you able to understand what I'm trying to say? So what is mentioned in the questions? They mentioned the word difference. Means you choose two random boys from that particular school. You take the data of heights of both those guys and you find the difference. It should be less than 3 meters. 3 meters now 300 centimeters. So if the difference itself between two people should be 300 centimeters now, one person, let's say minimum should be 600, others should be 300. 600 meters now, how many feet? 1 feet is how many? 30 centimeters. 600 feet now, 20 feet. Not possible. Okay, generally 1.8 meters will come, 180 centimeters comes to 6 feet. Okay, so is this a universal relation? Yes. You take the difference between any two boys, it will definitely be less than 3 meters. Right? So this is a universal relation. Are you guys able to think about that? Hope I'm not fast, right? Next. So we saw trivial relations. The next type of relation in set A that we are going to see are of 3 types. One is called as reflexive, the second is called as symmetric, and the third is called as transitive. If all the 3 are satisfied, we call it as equivalence relation. What did I say? First is reflexive, second is symmetric, third is transitive, and if all the 3 are satisfied, we call it as equivalence. Okay, shall we try to understand what they are? Okay, so relation R is defined in how many sets? One set A. So relation R in set A is said to be reflexive if R is equal to what, guys? If A comma A, if every ordered pair is in such a way that the first element and the second element are the same. For example, I wrote this. I have a set 1, 2. Okay. So I have what set 1, 2. I have another set 1, 2. If I write the Cartesian product, I get 1, 1, 1, 2, 2, 1, 2, 2. So from that, for me to form a relation, I am free to choose elements. I am free. Nobody is going to restrict me. So I will choose those elements 1, 1 and 2, 2, and I will put it in a separate set. What am I doing? 1, 1, 2, 2. I'm putting in this mug. Okay. And what is the type of relation that is available in this part? That is what is called as reflexive. Okay. Are you guys able to understand? So that is what the mathematical definition is. If it is called as reflexive, if A comma A belongs to R for every element A that comes from which set? Comes from the set capital A. Okay, it takes some time for you to master this thing. But as of now, try to understand with the examples. So slowly you will be able to master this. So I'm saying if at all you are not able to follow this kind of notation, concentrate on what I'm trying to speak about. Is there anyone having difficulty with this? You're comfortable, right? Those who are online, are you guys able to understand? Shubham, Hamsini, and Arvind?
Yes, sir.
Yes, sir.
Right. Okay, please take down notes. Okay. So I'm taking example 2. So example 2 says, show that R is an equivalence relation. But as of now, let's not worry about equivalence. I've told you that equivalence means it should satisfy all the 3. Okay. So in this problem, I'm only going to look at the scenario of whether it is reflexive or not. Let's try to understand. Okay. So let T. Okay. T is a set. Instead of A, they gave T. It's a set of all triangles. What do you mean by all triangles? So that set contains scaling, isosceles, right-angled isosceles, right-angled, whatever it is. All triangles are there, and you need to frame a relation R in set T such that what kind of a condition is it supposed to satisfy? R is equal to T1, T2 such that T1 is congruent to T2. So I need to write the ordered pairs in such a way that one triangle, the first triangle of the ordered pair is always congruent with the second triangle in the ordered pair. So what do you mean by congruent generally? Congruent generally means they're same. Right? When you say congruent, the sides are equal and the angles are equal. They're not in proportion, they're equal. If they're in proportion, you call them as smooth. So here they use the word congruent. Okay. If that is going to be the case, is it first of all a reflexive relation? Is it a reflexive relation? Because how can I say it's a reflexive relation? So for me to have a reflexive relation, how should the ordered pair look like? Both the elements in the ordered pair should be the same. So I have triangle, let's say T1, T2, so on. I have another set T1, T2, so on. I will have the Cartesian product T cross T as what? T1, 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 T2. It keeps on going like this. And what will be the last one? Tn comma Tn. Let's assume there are n triangles of that sort. So what kind of ordered pair should I choose? T1 comma T1, T2 comma T2. So if I write a relation R like this, if I write T1 comma T1, T2 comma T2, so on till Tn comma Tn. So first, I don't know whether it is equivalence or not. I have written it blindly. Now only I'm going to concentrate on whether it is equivalent or whether it is reflexive or not. Now what is the condition saying? If you take that ordered pair, the first triangle should be congruent to the second triangle. Is T1 congruent to itself? T2 congruent to itself? So how you write it in the exam is, since every triangle is congruent to itself, you can say that there is a reflexive relation. Am I clear? So that is the meaning. So that is what they would have written. Since every triangle is congruent to itself, that is the logic they gave. But we try to analyze it by dissecting the ordered pairs. Are you guys able to understand? Right? So this is the outline. So one last thing we'll see and we'll wind up. So next is symmetric. Symmetric name itself is suggesting. Okay. Symmetric means something like a mirror image. Okay. If 1, 2, then you write 2, 1. So if 1, 2 is an ordered pair, then 2, 1 is a symmetric ordered pair. Right? What is it? Okay. So when can you say a relation from that Cartesian product is an ordered pair? It is symmetric if A1, A2 belongs to R. So that is already a part of R. And you are able to find another ordered pair, which implies A2, A1 also belongs to the same Cartesian product. Then you can say that this particular relation is symmetric in nature. What am I trying to say? If you are able to find an ordered pair A1, A2, and you are able to also find that A2, A1 also belongs to the same relation, then you call the whole relation as symmetric. Let's try to understand it in a simpler way. Okay. So what I'm trying to say is, in this, I have the ordered pair that we have written. So in the T cross T, for you to prove something is reflective, you need to choose the ordered pairs which are identical, same elements. For you to prove symmetric, what you need to do is you need to take the combination 1, 2, and you should find whether 2, 1 is also existing in it. So what I will do is I am able to write a relation R. Okay, I'll write a relation R dash, for example. If I choose triangle T1, T2, I am choosing this. Okay. If I say T1, T2, what do I indicate or what do I mean according to this system? I am saying T1 is congruent to T2. If that is the case, will T2, T1 also belong to this relation? If T1 is congruent to T2, the vice versa is also true. So like that, if I take any particular order pair of the order 1, 2 or 1, 3, I can always find the reverse also. So if suppose I take T2, T3, then I can always find T3, T2 also to be a part of the same relation. Then what I can say is it is a symmetric relation. So how did they give the explanation? Further, T1, T2 belongs to R. You have already written. This implies that T1 is congruent to T2, which also implies the vice versa. That is T2 is congruent to T1, which implies that T2, T1 also belongs to the same relation R. Okay. So the tricky part with respect to this chapter is you will understand the concept, but how to present the exam is very important. So this is the way you need to write it. Okay. You need to explain what is there in your mind. Okay. Hence, R is symmetric as well. Having said these two things in mind, we will try to work on what is transitive and equivalence in tomorrow's class. But before that, I want to stress on one important point. When I say reflexive, right? So if I take A cross A is equal to 1, 1, 1, 2 till 4, 4. Okay, if I write a relation R is equal to 1, 1, 2, 2. Can I call this as reflexive? No. I cannot call this as reflexive because what is missing? All the elements should be there. For every element from set A, there should be a counter element which is exactly the same element. So I can call it reflexive only when I have 3, 3 and 4, 4 also. If any one is missing also, you cannot call it as reflexive. But that's not the case with respect to symmetric. That's not the case with respect to symmetric. For example, you are able to find T1, T2. You can still call it a symmetric if you are able to find T2, T1. Suppose you have T2, T3, and you don't have T3, T2, still it is a symmetric relation. You're able to understand? So not every element should have. Whereas with respect to reflexive, every element should have a counterpart. Are you able to understand? So this is the outline. Then we'll discuss about the transitive function, transitive relation and equivalence in tomorrow's class, and we'll solve some problems. Right? So that's it. Any other doubt? Clear, right? So please tell me. You can call it. Others can be anything. It's not necessary that it should stop only with that. 1, 1, 2, 6. That depends on what set you're talking about. 1, 2, 3, 4. So what she is asking is, I have a set 1, 2, 3, 4, which is A. I have ordered pairs 1, 1, 2, 2, 3, 3, 4, 4, and 1, 2. Can I still call this as reflexive? Answer is yes, but you cannot call it as symmetric because 1, 2 is there, but 2, 1 is not. For example, you had something like this: 1, 2, 2, 1, and 1, 3. Now we can call it symmetric. So that's it. Okay. So remaining things we'll discuss in next class. Yeah. So 1 minute. Yeah, I'm sorry about it. I mentioned it wrong. You cannot call it as symmetric because the statement says for all. I missed it. I'm sorry about it. For all elements A1, A2 that belong. So if there is an element 1, 3 in the ordered pair that is present, it should have 3, 4. Okay. So for example, in this problem, what has happened? You found T1, T2. So triangle 1 is congruent to triangle T2. And T2 is congruent to triangle T1. So for every ordered pair 1, 2, you are able to find the vice versa also. If you have 2, 3, you'll be able to find 3, 2. So it is something like that. So correcting my statement, yes, you need to have that also. So if 1, 2 is there, you need to have 2, 1. 1, 3 is there, you need to have 3. Okay. So that's how it works. So transitive, I'll explain it more. Sorry? Yeah. For all it is there. See, for example, I'll explain with this problem. It is for all. For every. Which one? 3, 3, 4, 4 is there. That can be there. See, for example, I take this problem. Listen. If I take, show that the relation R in set A 1, 2, 3 given by the relation 1, 1, 2, 2, 3, 3, 1, 2, 2, 3 is reflexive, but neither symmetric nor transitive. Forget about transitive for now. Okay, so 1, 2, 3. So how many such ordered pairs should you have for you to call it as reflexive? 3. 1, 1, 2, 2, 3, 3. Are they there? So it is reflexive. That's it. With that, reflexive job is done. Next, you need to search for transitive. So you have the elements 1, 2. For 1, 2, do you have the elements 2, 1? You don't. Similarly, you have 2, 3. You don't have the element 3, so it is not symmetric. That's why they told it is not symmetric. So as 1, 2 belongs to R, but 2, 1 is not a part of R, you cannot call it as. Similarly, R is not, okay, transitive I have to explain. Right? Transitive will see. Okay, understood? So that's it, guys.